Osmosis. Does anybody know what osmosis is? Have you talked about osmosis before? Well, it's a very interesting phenomenon. You know what it is? Osmosis has to do with the movement of water. And so the question is, well, why would water move? Oops, period. Why would water move? Well, I'm going to draw you a picture and show you why water would move. Let's say I had a whole bunch of molecules over here, and there was a very high concentration of molecules. And over here, there was a very low concentration of molecules. We would expect, by diffusion, for these molecules to move from the high area to the low area, right? That's diffusion. But what if something was in the way? What if something was blocking their motion? And that something would be a membrane. So if I put a membrane in between here, like the inside and the outside of a cell, this is my short form for drawing a membrane, right? We all know what that really represents from yesterday. Then these black dots on this side, on the left side where it's high concentration, they might want to move to the right, but maybe they can't because they can't get through the membrane, right? There's a word we use to describe the characteristics of the membrane, and the word is permeability. Permeability. If a membrane is permeable to something, it means that it will let it through. So this membrane could be permeable to this solute, this black dot, or maybe it's not. And the permeability of the membrane depends on, for the most part, it depends on what the membrane is made of. Okay? If you are a fat-soluble or lipid-soluble molecule, you could slide right through the membrane. We talked about that. But if you're not, you may have to be transported by special protein gates, right? If you're large. If you're small, you could squeeze right through as well. So oxygen would squeeze right through. But some membranes have different proteins in them. So that means they have different gateways, which allow different things in and out. So if we have a membrane here that is impermeable, impermeable means you can't let it through, right? If you're impermeable to this black solute, it can't get through. So it tries to go through, but it can't. It's turned back by the membrane. And therefore, the concentration gradient can't be evened out. Mother Nature hates gradients. She hates them. She likes everything to be nice and even. And if there is a gradient, Mother Nature will work very hard to wear it down, to get that gradient back to normal. That's what diffusion is, right? It's all those molecules trying to get to the other side to sort of erase the gradient and bring it back to normal, nice and evenly distributed. Now, there's two ways, though, that you can get concentration to lower. Obviously, if we move the solutes, the black dots, the molecules, to the other side, the concentration over here will get lower. But what if we take water from the other side and let it come over here to kind of water it down? If you increase the volume of water, then that means there's less solute in this bigger volume of water, doesn't it? So another way for Mother Nature to get rid of a gradient is to have water. I'll just put a circle here to well, you know what, let's put an H2O. Remember how I said water was a very small molecule? Remember that? And it can easily go through almost any membrane. So H2O, water, let me just erase this, can move through the membrane to the other side. So because the membrane here, we're going to write the word impermeable membrane. Impermeable, which means it is not letting the black solute through. But water, no membrane is impermeable to water, really. No, not really any sort of biological membranes, because water is a small molecule. I suppose if you had a piece of saran wrap, well, that's a membrane that's impermeable to even water, right? Water can't go through it. But in real life, there's no saran wrap. in biological systems mostly, they're all made of these membranes which will allow water through. So as the water seeps through, what it does is it waters down the left side of this, and the concentration lowers. The concentration goes down. So it's kind of the same effect. It's reducing the gradient, but it's water that's moving. And this is what osmosis is. What's interesting is water is moving from the low concentration area to the high concentration area, but it's doing it automatically. Another way to think of it is to focus just on the water. If you focus on the black dots, which are the solute, right, then you have high on the left and you have low on the right. But if you focus just on the water, there's more water on the right side. So this is kind of like the high area for water, and this would be the low area for water. There's less water because there's more solute. That's not really true. It's kind of a trick. It's like a little mental trick that I use. But water is moving from high to low if you focus on the water, right? So it does kind of make sense. Unfortunately, we don't use those definitions. We always describe a gradient according to the solute concentration. So although it's a convenient way to think of it, by definition, that's not the way it's described. It's described as water moving from low concentration to high concentration. And the reason is because the natural diffusion from high to low is blocked by an impermeable membrane. Does that make sense? And that's osmosis. And of course, it all depends on the membrane. Some membranes can be impermeable to one thing and not another. But like I said, because water is such a tiny little molecule, H2O, compared to like sugar, glucose, and those bigger ones, it pretty much can slip through no matter what. And there's a little cool experiment we can do to actually watch osmosis happen. So maybe we'll set that up for tomorrow, and we'll just kind of do a little experimente to see that will work. Okay, any questions about osmosis? So it's the movement of water from a low concentration to a high concentration due to the fact that the normal diffusion from high to low is blocked by a membrane. You can't have osmosis unless you have a membrane to block, because without the membrane, the molecules that were in black here, they would just drift over. So you have to have a membrane in order for osmosis to occur. And osmosis is a very important biological process. Cells make use of osmosis in the movement of water a lot, in a lot of different ways. So understanding that is critical to some of the processes we're going to talk about later. Okay, I'm going to stop that one. Any questions?